Hello everyone, and my name is Yang Song. I'm a practice-based PhD researcher from the School of Architecture, University of Liverpool. So I'm really excited to join our Ascadi 2022 conference today, and hopefully we can learn a lot from each other. So the title of my research that I like to present today is called Augmented Menstrual Design, a design method using augmented reality AR for customized breaking design algorithm. So this research belongs to the conference theme number 4, virtual environment and emerging realities. And this practice-based research is supervised by Professor Richard, who is the chair of architecture and visual arts. And he is interested in digital database, immersive media, VR and AR technologies. And this research is also supervised by Asterius, who is the director of architecture school. And his research includes about parametric design, generative design, VR, AR, robotic and digital fabrication. So they are also the co-authors of this paper. The Augmented Menstrual Design Project presents experimental research about the developing and applying augmented reality AR technology for customized design algorithms, and exploring a real-time interactive and spatial-free design method for the early architectural design stage. So we aim to resolve the current 2D-based design limitations and provide architects with a 3D to 4D immersive precision in AR for a practical and easy-to-use design method. So furthermore, with the reference of the COVID-19 pandemic, we propose this design method that could break through the set accessibility and constraints by breaking barriers of physical space. And our finding highlight the advantage of immersive design in the initial stage of architectural drawings, which gives designer a better spatial understanding and design creativity, as well as challenges raised of the limitation of current AR devices and the lack of real physical simulation in the design stage. So towards these aims, we applied augmented menstrual design into 2 prototypes. So the first prototype is prototype A, user interface UI immersive design, in which interactive inputs will communicate with design algorithms in AR through the inputs from screen-based UI app on mobile devices, such as smartphones and tablet or iPad. And prototype B is the intuitive interaction immersive design, in which the interactive inputs will be translated into design algorithm directly in AR through hand gesture on hand-mounted devices, HMD, for example, like Microsoft HoloLens 1 and 2. So this is the flowchart of the augmented menstrual design research, which describe each key steps of the AR-assisted immersive design method using the UI immersive design prototype, which is colored in red, and the intuitive immersive design prototype, which is in green, and the related plugin and software for each step shown below. So for prototype A, UI immersive design, we applied an AR UI that can extract the basic unit and parameter settings from the corresponding design algorithm in design software like Rhino and Grasshopper. So this tool enabled the designer to achieve on-set real-time design and visualization modifications through the UI-based interactions from mobile screen, such as parameter settings, data adjustment, and also QR code marker recognition from the physical world. And the design algorithm has already been preset from our design library, representing different break-based structures. And architects can also create their customized design algorithm and interventions according to their needs and extract the relative parameters in our open platform AR UI through Grasshopper to the mobile device. For example, we design a break column to validate this UI immersive design method. So first, we can scan the QR code through the smart device for design coordinates from physical world to virtual. And next, the designer can build their own AR break column with AR UI by developing and adjusting the related parameters through the design screen inputs and modifying the structure outcome on set as holograms. And last, the outcome will be recorded in Grasshopper. Multi-designer or remote users can scan the same QR code to access the design outcome, as well as sharing or modify, which provide a remote design workflow. However, the UI immersive design tool has some limitations as well. For example, it constrains the possibility of design algorithm by only adjusting limited parameter sliders. For some complex or curved surface, the mobile AI cannot achieve from that. So based on this point, we develop another prototype, prototype B, which is the intuitive immersive design. So for this method, we employ the method of gesture recognition, path tracking, and QR code marker tracking to transform the intuitive human movement and hand gesture interactions into a design algorithm language. So the basic parametric design logic has been predetermined in our database. And the key parameters, such as spline curves or NURB surface, will be determined the shape of the design outcomes, will be input intuitively through designer's gesture, tracking, and recognition in AI environment. And the designer can develop or customize parametric design logic and the critical interactive parameter according to the algorithm through Grasshopper. So for example, we use the design of a brick wall to validate the intuitive immersive design. First, the geometry concept was based on the arc marker or QR code that can be placed on set on the floor as a center or reference point of the brick wall. And after scanning the marker through HoloLens, the design coordinates will be picked up from the physical to virtual in the design software. And second, the designer can use tap and hold hand gesture in HoloLens to draw a virtual spline curve of the brick wall in AR. And the spline curve will be displayed as holograms on set with several control points on it for the user to modify and adjust the shape. And after that, in parallel, the spline curve or the spline surface will be generated and extruded directly with the AR holographic control points on that. So after the surface is determined, the brick holograms will be filled in the surface automatically, and the designer can adjust the number of the brick, the angle of the brick density, etc. By using the same method in prototype A to play with the AR UI from HoloLens, or even set the interference point to do more fancy or customize the algorithm design. So the augmented menstrual design research developed and verified an AR-assisted immersive design method that successfully applied design algorithms in AI environment, exploring a real-time, interactive, and spatial-free design methods in early architectural design stage for brick structures. And closely practicing the AR-assisted design process, as well as analyzing the outcomes, it can be concluded that the proposed immersive design method does fulfill our predetermined assumptions and offer a new way to modify design drafts and preview on-set through AR in real time. And this on-site design preview function breaks the conventional 2D-based design methods, provide designers with a 3D to 4D immersive perception in AR for more practical design. And moreover, the application of AR technology in the early architecture design stage enable the user to improve their cognition and understanding of space, trigger reflection and remodeling of the architectural design process, and cultivate their design creativity and outcomes variety. So our AR-assisted method gives architects or user more freedom, as well as it is remote, collaborative, and multiple designer outcome sharing functions, break through the conventional 2D-based design medium. And we will systematically develop this AR-assisted method to test and apply it for more different architectural form or material in the early architectural design stage. And these are the reference that I use in my paper. And moreover, as a part of my research validation, I held a workshop on 10th of October with our conference for evaluating one of the preliminary AR UI immersive design methods. So there were 44 participants from Beirut Arab University with architectural background. So I introduced the workflow to them and let them try the user interface immersive design, which was the prototype one in my paper, directly with preset design algorithms from our design library. So the idea and attempts of designing structures in AR environment actually help the participants to clarify the sense of scale and inspire their design creativity, give the possibility for them to enter the AR design process faster and more effectively for the future development. So at the same time, this interactive design also breaks the participants' cognition of traditional architectural design methods and media, providing them with a more effective and novel 3D to 4D design experiments in AI environment. So here are some more design outcomes from the ASCII workshop participants. And if you are interested and want to see more, you're welcome to join the workshop outcome session this afternoon at 3 p.m. And thank you. That's all for my presentation.